Okay, well, another week, and just a few more weeks of this, and you'll be done with the year, and hopefully life will get back to normal soon. We're going to go to page 299 in your books, page 299, if you can turn there in your books, and we're going to do solving radical equations. Solving radical equations. Now, the plan for this week, just so you know, is today, will be Monday's lesson. We'll do lesson 8.8. On Tuesday, very short lesson, we'll do the Pythagorean theorem, and you'll do a few of those, and then I'll turn you over to the review of radicals, which will be Wednesdays, rest of Tuesdays, Wednesdays, and then there will be a test sent home that you'll have to do on Friday over chapter number 8. So that review right there is your key to it. All right, so I'm going to allow it to be an open book test, so you're allowed to use your book, all right, because it comes down to whether you can do it or not. So I'd like you to, if you need to be refreshed on something, that's fine too. So there'll only be 2 videos this week, and then there's the review lesson, that's found on page 307, and then a test. All right, make sure you watch the videos. Some of you, I won't mention your name, but some of you have been skipping your videos and just trying to wing it, and your grades, it showed last week. All right, so what I graded, it wasn't as good as the previous week, so hope you'll sharpen it up a little bit. All right, so page 299, let's do solving radical equations. If you'll read with me, it says top of the page, recall that an equation is a statement that 2 expressions are equal. If one or both of the expressions is a radical expression with a variable in the radicand, then the equation is a radical equation. For example, the square root of x plus 4 equals 9 is a radical equation. The entire expression, x plus 4, is in the radicand. However, x plus square root of 3 equals 7 is not a radical equation because no variable is in the radicand. Now remember, a variable is a letter. All right? So if you have an equation that has a letter underneath the radical sign, then it is a radical equation. If there's just a number and only a number under the radical sign, it's not a radical equation. Okay? That should make sense. If there's a letter right there, see the example they gave you in that reading? X plus 4, the square root of that equals 9. That is 1 because the variable x is under the radical. Next illustration, x plus the square root of 3 equals 7 is not a radical equation because only the square root of the 3 is underneath the radical sign. All right. Next paragraph says, when solving a radical equation, first use the properties of equality to arrange the equation so that the radical is isolated on one side and all other terms are on the other side. Squaring both sides will eliminate the radical, but be aware that squaring both sides of an equation may introduce extraneous roots. In other words, they can't be solved. Right? Finally, simplify and solve the resulting equation. When checking the equation, disregard the solutions that do not solve the original. Those are extraneous. Right? So, you have 5 steps to solving. Right? The 5 steps to solving a radical equation. Look at your book there. Number 1. Isolate the radical. Isolate the radical. So you want to get the radical all by itself by moving things to the other side. Number 2, square both sides. That's how you get rid of the radical. 3, simplify both sides. Like terms together, letters on one side, numbers on the other. And then solve it. Then you can check it. All right? Now, having said that, all right, this is probably, this is one of those lessons where you'd be like, what? Oh, okay, that's easy. All right, so you may say, well, that's been every lesson, right? Maybe, but that's what happens when you have me as a teacher. It becomes something you can teach. All right, so the first one says the square root of x equals 5. Let me find some chalk here. You know how much I love chalk. So the square root of x equals 5. All right, so what we want to do, I'm going to go through the long process here. To solve it, number 1, you want to isolate the radical. Done. It's all by itself. It's on one side. All right, number 2, square both sides. So to get rid of this, all right, I'd have to multiply it by itself. All right, and so if I squared this, multiply itself, it would give me x squared, which you can solve that, which is x. But what you do to one side, you have to do to the other. So it equals 25. So x equals 25. And if we go back and check it to our original problem, the square root of x equals 5. If we say x is 25, the square root of 25 is 5. So it works out great. Yay! Right, so you're able to solve it. But again, remember, isolate the radical, square both sides, then answer the problem. That's pretty much all there is to it. The next one says this. In the next illustration they give us, the square root of x minus 2 equals 5. Now, I'm going to show you something. All right, so look up. All right, don't daydream. Catch this secret, Pastor Burke, secret to great success in algebra. All right, when you square this, instead of going through an entire process of saying, how do I square this? All right, it always equals itself without the radical sign. Right? So x minus 2, if I square it, it equals x minus 2. Ta-da! All right, all you have to do is just take away the square root sign, really. Just don't forget to square the other side. So that would equal 25, because I really squared that. Now x minus 2, I'm going to add 2, and x equals 27. And if you want the proof of that, 27 minus 2 is 25. The square root of 25 is 5. Okay, so, again, just don't forget when you're squaring the radical, all right, it just equals itself. I mean, if I squared 6, all right, it equals 6. Because 6 times 6 is 36. The square root of 36 is 6. But it equals itself. Just don't forget to do the other side. That's the key. Because if you forget the other side, it messes everything up. All right? The next illustration they give us down on the next page. On page 300. Page 300, if you turn over there real quick. All right, they have a longer question for us. Switch pieces of chalk. We have the square root of x squared plus 5x minus 2. The square root of x squared plus 5x minus 2, all underneath that radical sign. And then plus 4 equals x plus 1. We good? We're good. All right, so the instructions again, if you remember, are to number 1, isolate the radical. So I want this radical all by itself. So there's a 4 over here that's intruding. I need to get rid of it. To get rid of something in the equation, you always do the opposite. So if that's plus 4, I'm going to minus 4. What I do to one side, I'm going to do to the other. Now I'm left with the square root of x squared plus 5x minus 2 equals x, and then you have a plus 1, negative 4, so minus 3, because a positive 1 or negative 4 gives you a negative 3. Now, I have to get rid of the square root by multiplying by itself, for squaring it. But what will that equal? If I square x squared plus 5x minus 2, the square root of it, and I square it, what does that equal? It equals everything without the sign. X squared plus 5x minus 2. All right. Again, how did I get that? Because technically, I did this squared, which equals that without the square root sign. But what I do to one side, I got to do the other. So it's x minus 3 times x minus 3. Here's that foiling thing. All right, so over here, I'm going to leave this by itself. X squared plus 5x minus 2 equals, first outer, inner, last. X times x is x squared. My outer give me negative 3x and a negative 3x for the inner, so it's negative 6x. And then a positive 9, negative 3 times negative 3. With me? If not, be kind and rewind. Sorry, 80s joke. All right, but now I'm going to get this x squared and go over here by subtracting x squared. And it eliminated my x squareds, if that's a word. Then I'm going to take now, I have negative 6x. So I'm going to take that over here by adding 6x. Add 6x, which gives me 11x minus 2 equals 9. I'm going to add 2, 11x equals 11. Can you still see that? Barely. All right, and then I'll jump over here. 11x equals 11. Divide by 11. X equals 1. Don't you love a problem like this? Equals 1. Hey, but if you go back and fill on ones instead, you'll find the answer. Okay, so they give us one more illustration. Let's go ahead and do that one on the bottom. And then we'll do some of these, okay? No, no, 2 more illustrations. Sorry. All right, we have the square root of 3 minus 2x equals x. So I've isolated the radical by itself. It's over here. So I'm going to have to square it to get rid of it, which will equal 3 minus 2x. Just don't forget to square that side, which is x squared. Now, this is from about a month and a half ago. All right, I'm going to bring this x squared over here by subtracting it. All right, and so when I subtract that, I'll just do it that way. All right, so I subtract x squared, and then I have negative x squared. I'm going to put it in order now. Negative 2x plus 3 equals 0. I don't want that negative, so I'm going to change all the signs. All right, which gives me x squared plus 2x minus 3 equals 0. All right, and that's kind of catches up where we are. And then, remember, we can't really say, well, there's nothing else we can do with this. Well, remember, we broke this down into 2 binomials. Okay? And then I'm going to have x and x plus minus 3 times 1. 3 times 1 is negative 3, positive and negative. My outer will be negative 3x. Oh, I did it wrong. Whoa. All right. There we go. And so that gives me a positive 2x for my outer inner. Then remembering at this point, you just solve each of these separately. So I have x minus 1 equals 0, x plus 3 equals 0. So x is going to equal 1, and x is going to equal negative 3. So those are my 2 answers. All right. And if you go back and fill it in, it actually works. So, one more illustration to give you on page 301. There's some fascinating reading on how old an antique clock works, because I'm sure all of you are going to read it. All right, but at the bottom, right? This is this. One more illustration. We have the square root of 2x plus 5 equals the square root of 4x minus 3. Now, to get rid of I hate chalk. Did you know that? To get rid of the square root, you have to square it. The radicals are isolated all by themselves, so I don't have to move nothing. So I have to square that and square that. So if I square this, what do you get? You get 2x plus 5. If I square this one, what do you get? 4x minus 3. Pretty easy. Subtract 2x, subtract 2x. Now I have 5 equals 2x minus 3. I'm going to add 3, 8 equals 2x, divide by 2, and x equals 4. Good. So, like I said, this isn't, once you get the hang of that, just square the one side, well, square both sides, but you do the one side just by dropping the radical. If they're both radicals, you just drop the radicals, and then you solve the equation. All right. Simple. Yay. All right, so look at page 302. Let's do some of these. I'm just going to do a few with you. I will start out by saying immediately when you have the square root of a negative number, like on number 3, you may know what the answer is. That is, you can't do the square root of negative numbers, so the answer to all those are always going to be no solution. So I'm looking at number 3, 8, 9, and maybe another one. You get it? No solution when they have the square root of a negative number. Now let's go up there to number 1. The square root of x equals 4. Alright, to solve it, I have the radical sign isolated. So I'm going to square that x, which gives me x. Square this next side, 16. Done. X equals 16. You're welcome. Alright, you can handle this, right? Let's jump down there. You know number 3 has no solution. Let's do number 5. Number 5 says the square root of 5x then a plus 3 equals 5. Correct? Yes. All right, so the first thing you have to do is isolate the radical sign. So I need to get rid of this plus 3 by subtracting 3. Now I have the square root of 5x equals 2. 5 minus 3. I'm going to square this to get rid of it, which is 5x. I need to square this because I squared that side. 2 times 2 is 4. Divide by 5. Divide by 5. X equals 4/5. Let's do number 12. Number 12, I'm just picking these randomly. Number 12 says 7 plus the square root of z minus 5 equals 15. Isolate the radical first. So I got to subtract the 7. I have the square root of z minus 5 equals 17 minus 5 is 8. All right? And then to get rid of the square root, I got to square it, which equals z minus 5. But it equals 8 times 8. I got to square that side too. 64 plus 5, and z equals 69. Let's jump all the way down there to the last one, right? The very last one. Then I'm gonna turn you loose. All right. Sorry, I have to look at the book on this one. I have the square root of 2x minus 5 minus the square root of 6x plus 1 equals 0. Now, what I want to do is I want to isolate the radicals. So I know I have two radicals, so let's isolate them both. All right, so I can do that by taking this one and moving it over there. How would I do that? Since it says minus, I'm going to add it. So now I have 2x minus 5, the square root, and I added the square root of 6x plus 1. Just got rid of it. Do the same thing over here. So it equals the square root of 6x plus 1. I'm going to square both sides to get rid of the radical signs, which basically is the same thing without the radicals. 2x minus 5 equals 6x plus 1. Let's move this 2x over here to avoid negatives, because we hate negative people. All right, so I'm going to subtract 2x, subtract 2x. Now I have negative 5 equals 4x plus 1. Subtract 1, subtract 1. Negative 6 equals 4x. Divide by 4, divide by 4, and x equals a negative 6 over 4, which would be 1.5. X equals negative 1.5. So, again, I think you can handle these. Right? Isolate the rational, square it, make sure you square the other side, then solve the equation. All I want you to do is numbers 1 through 24. All right? 1 through 24, that's it. Told you. Easy stuff this week. All right? Except for the giant test. All right? But, so again, tomorrow we'll do lesson 8.9, which is even shorter than this. All right? Because I'm not doing part of it. And then you'll have a review section, and then your test over chapter number 8. All right? See ya.